G'day team, welcome back to another video. So we're going to be continuing with our trigonometry work and our work with building up to the unit circle. So hopefully you're all over radian measure after the last video, because that idea is going to be super useful for this video and pretty much every video that will be coming into this playlist from now on. So today we're going to be looking at the arc length and the sector area, okay? So please have a look at this diagram here, all right? It gives us all of the information we're going to need to know to understand the questions coming. So we have a circle with the center point here. We have our radius, okay? A chord is any line that touches each edge of the circle that doesn't pass through the center, otherwise that would be the diameter. The area that this chord chops off from our circle or separates from our circle we call a segment. And then our sector is the area that looks like this. Okay, so it's formed by two radii and the arc length. Okay, so we have the arc, two radii, and then the sector is in between. So we often will describe arcs, sectors, or segments as major or minor. All right, so as the name sort of hints, the minor segment will be the smaller segment by the chord, and the major segment will be the larger segment. Same thing with arc. Minor arc A to B is this red one, and major arc A to B is this pink one. It is bigger. All right. So arc length. So remember that theta measures how many times longer the arc length is than the radius. So remember we're talking in radians here. So if we have a diagram looking like this, if theta measures how many times longer the arc length is than the radius, then theta is equal to the arc length divided by r. Okay, so we're looking at how many times bigger L is than r. We're looking at that ratio. So if we want to calculate the arc length, we're going to multiply this equation on both sides by r. Okay, and that's going to give us the arc length is equal to theta times by r. And that is the formula that we're going to use. So for theta in radians, our arc length is theta r. For theta in degrees, so sometimes you might be given your angle in degrees. The arc length is whatever angle you have divided by 360. So we're looking at that portion of the whole circle. I'm going to multiply that by the circumference of the circle. Okay, so we're going to only get this fraction of the circle. All right, so these are your two formula. Please make sure to double check what your angle is given in. If it's given in radians, use this one. If it's given in degrees, use this one. All right, it's really important to have both down. So the area of a sector now. So remember, theta is measured in radians for this purpose. So if theta is measured in radians, then there are 2 pi radians in a circle. Remember we defined 180 degrees to be pi. If a circle is 2 times 180 degrees, then the circle is 2 pi radians, okay? So the area of the sector AOB, so this sector here, or highlighted in green, is this fraction of the total area. So this makes up theta radians on 2 pi, fraction of the whole circle. We're going to multiply that by the area of the circle, which is pi r squared. So we have theta on 2 pi times by pi r squared. We have a pi in the numerator, pi in the denominator. They cancel out to be equal to 1. So we're left with half times theta times r squared. And that is our formula there. Again, if you have your angle measured in degrees, that equation does slightly change. So we have that fraction of the circle again, times by pi r squared. So in radians, the sector area equals half times theta times by r squared. If your angle is measured in degrees, your area of your sector will equal theta over 360 times by pi times by r squared. So again, we have two equations depending on the question. So we're going to go through a couple questions together. So a sector has radius 7 meters and an angle pi on 6 radians. Find A, the arc length, and B, the area of the sector. First thing we look for is to see what our angle is measured in. We see that it's in radians, so we're going to be using the 2 radian formula, okay? So part A, to find the arc length when our angle is measured in radians, the arc length is equal to theta times by r. Theta is pi on 6, r is 7, so that means the arc length is 7 pi on 6 meters, all right? Part B, the area of a sector when our angle is measured in radians is half times theta times r squared. So that's half times by pi on 6 times by 7 squared, which gives us 49 pi divided by 12 meters squared. So remember, we're again dealing with measurement, so our units are super important. Example 2 that I want to go through. So sometimes you'll be given the arc length and the radius, or the area and the radius, and you have to find the angle, okay? And we're going to be rearranging these formula to do so. So a sector has radius 12 centimeters and an arc length 15 centimeters. Find the angle. So if it doesn't determine what you are measuring your angles in, I want you guys to start getting into the habit of using radians, okay? It's going to be super important coming up in this topic, all right? We often use trigonometry in radians, so I want you to get used to using radians. So to find the angle, because we're using radians, L, so the arc length is equal to theta times r. That means theta is equal to the arc length over r, all right? That means theta equals 15 over 12. Theta is 5 on 4 radians, okay? Really making sure we're using those units. All right, now that we have theta, we can find the area. Again, because we're in radians, area equals half times by theta times by r squared. Replacing the theta we found in part A here, so half times by 5 on 4 times by 12 squared. And that's actually equal to 90 centimeters squared. So that actually works out to a really nice number. All right, so there are times when you are going to have to rearrange these equations to solve for unknowns. Make sure you practice laying it out step by step so you are getting the algebra correct. All right, hopefully this helped, and we will see you guys next time.